instead of parentheses, just to kind of stress that out of this entire expression, I'm pulling an x minus a out of this one, and then x minus a out of this one. So when I pull it out of this one, what's left? What's still there? X plus a, right, is still here. I'm going to put it in parentheses just to put it there. So that's what was left when I pulled this out of this. I had that. And then over here, I'm pulling this away, so what's still left there? Minus 2. And then all of that's over x minus a. Can these x minus a's cancel? Yes. So we're left with limit x approaches a. Okay, here, do I really need these parentheses around x minus a? No, around x plus a. X plus a minus 2, right? That's what I have. So this is x plus a minus 2. That's all that's left here. And now, let x go to a, right? Let x become a, and what do you get? A plus a minus 2, which is 2a minus 2. 2a minus 2. That's the formula. So let's just recap. I hope everyone is okay up to this line right here, above my arm. Because that's just using the formula and plugging in what the function is, right? It's from here to here, well, I guess from here to the next line where things started to get weird. What was your name again? Brad? So Brad wanted to rearrange things and then start factoring. I'm not sure why you want to do that, but you have to try something, right? That's the whole thing. You got to try something. The whole goal was to try and get an x minus a to cancel. So the rearrangement here, and then noticing a difference of squares, and then pulling a negative 2 out, and then seeing the x minus a come out, that's all something that you're only going to get there if you have to try, right? You can't just look at it, you got to start. It's like you can't win the lottery if you don't play, right? You can't hit a home run if you don't swing. So you've got to do something. And if you need to start over, you start over, right? I wonder, is there any other algebra that could have got us there? Does anyone see anything else we could have done? Like at this point right here, could we have done anything different? Let's just look at it. Just looking at this numerator. Just look at the numerator for a second. Could you have done, like, you know, when you're doing factoring, when you have 4 terms, you try grouping, right? Grouping. Could you have done grouping on the first 2 terms? Like, what could you pull out of both of those? X, what would you be left with? X minus 2, right? And then over here, what could you pull out? An a or a negative a, up to you, right? Could I pull a negative a out? And what would I be left with? A minus 2, right? Does that work? Does that grouping work?
It does. Well, you got to pull it out. You pull out the, oh no.
No, these have to match, don't they? In order for grouping to work, this has to be equal to this, and they're not the same. And so this wouldn't work. Well, but you can't plug in yet. Okay. So what I'm showing you is that there are some things you could have tried algebraically that would have not worked for you. For this problem, the key was to see that difference of squares, and then proceed. So if you're sitting there going, well, how would I have known to do that? Well, that's why I'm here. That's why I'm showing this to you, right? So now you start to think, okay, well, I've seen before where I had to rearrange things and do difference of squares, and so maybe that'll come up again, right? All right, so we've answered part A, right? So the answer to part A, I'm going to put it right here. The answer to part A is 2a minus 2, right? That's our formula. So can you tell me then, what's the slope of the tangent line at x equals 1? So what are you going to do? Plug 1 into that formula. So using that formula, you get 2 times 1 minus 2, you get 0, right? What's the slope of the tangent line at negative 2? You go 2, plug in negative 2, then minus 2. What is that? Negative 6. Y'all see what I'm doing? Just replacing this in here, that in there, that's it. And then for part C, I want the equation of the tangent line at x equals -2. The equation of the tangent line. So how do we find the equation of the tangent line? Go back to that good old formula, y minus y1 equals all that stuff. So if I want to find the equation of tangent line at this point, what do I need? I need the slope of the line there, right? Do I have the slope of the line here?
Yes.
What is it? But at this point, at -2, do I know the slope of the tangent line? -6, right? So I have the slope. Do I have a point on the graph? Graph. Do I have a point on the graph? Well, I have the x-coordinate, don't I? -2. Do I have the y-coordinate of that point? So this is my point. What is it? That, no, careful. Well, is it? Oh. We have to plug in -2 here, right? So remember, to find the equation of a line, you need a point on the line, and then you need the slope. Here's the slope, right? I need a point. I've been given the x-coordinate. I just need the y-coordinate. The y-coordinate from the graph, though, right? Not from this formula. This is the y-coordinate. So plug -2 into this, and what do you get? -2 squared, 4, and then negative, yeah, you get 8. Do you understand where those are coming from? Are you sure?
Yes.
Okay, so now I'm just going to use this formula, y minus y1 equals m times x minus x1. All right, that's our kind of master formula for the equation of a line. What's y1? 8, so y minus 8 equals, what's the slope? -6. What's this? X minus -2, so +2. That right there is the equation of the line that should be tangent to this curve at that point. Let's check our work. So I'm coming over here. I'm going to start a new graph. First, I'm going to graph the original function. Y equals x squared minus 2x. Right? It's a parabola, right? It's a parabola. And we were interested in what was happening at -2. Do y'all see here's -2? I know it's hard to see on this side of the room, but do y'all see that's x -2 right there? I wanted to know, if you go to that point on the graph, what is the equation of the line that goes through that point as tangent? And we said it was, let me see, let me plot the point. It was -2, 8. There's the point that we're going through. And then we got the slope of -6. But let me type in the equation. Y minus 8 equals -6 times x plus 2. Shit, I did something wrong. What the hell? Oh, I didn't do that on the, there we go. There we go. Okay? Do y'all see the point? Do y'all agree that that looks like the tangent line to that curve? Yeah. One more thing while we've got this up here. Part B of this problem. Part B of this problem said what was the slope of the tangent line at x equals 1? And what did we say it was? 0. Do y'all see it over here? If you go to x equals 1, do y'all see the tangent line? Right there, right? Like this. Right? At 1, that point, it's flat, right? Flat lines have a slope of 0. So, makes sense. What do y'all think? You feeling all right? Okay, hold on. I'm just thinking about what I want to do right now. Do y'all want to do one more example before I move on, or should I just move on?
One more example.
You want one more? Okay. Okay, yeah, I can think of one right now that I like. How about this? I shouldn't have erased all that. Oh well. So new function. Let's try 2x minus 3 over x plus 4. So what I'd like for you to do is find the slope of the tangent line at x equals a. That'll be part A. Part B, I want us to find the, let me think about this, the equation of the tangent line at x equals -3. So first, give me a general formula for the slope of the tangent line at any arbitrary point A. And then once you do that, I want you to go ahead and find me the equation of the tangent line at that particular point, -3. So first thing, I write the definition. Limit x goes to a, f of x minus f of a over x minus a. That is that's like one of the most important expressions in Calculus 1, right there, that expression right there. Because it allows you to get formula for the slope of the tangent line for any function, so long as you can calculate the limit. All right, at this point, we just replace things, right? Limit x approaches a. What does the top left become? I'm going to pass out the sign-in sheet. I've been forgetting to do this. Just find your name, initial, pass it along. I noticed y'all were checking. If you could, try an initial in there. What's f of x?
2x minus 3 over x.
It's that expression right there, right? 2x minus 3 over x plus 4, right? Okay, that's the top left of this thing, right? Minus. Now, f of a is what you get when you plug a into that. 2a minus 3 over x, sorry, not x, I almost messed up. A plus 4, right? All of this over x minus a. Shit, right? Does that look like a complex fraction to you? Which means you need a common denominator to put the top two fractions together. So I'm going to multiply this top and bottom by what?
A plus 4.
A plus 4, and over here? X plus 4. Right. I think I want more room. Well, yeah, I want more room. Limit x approaches a. All right, I'm going to just write it here. It's going to be a plus 4 over a plus 4. I'm multiplying that times the first fraction up top, 2x minus 3 over x plus 4. And then minus, now I've got the 2a minus 3 over a plus 4. But I'm multiplying that one by x plus 4 over x plus 4. And then all of that, this is looking really bad, over x minus a. So this is a 1 I introduced, right? And this is a 1 that I introduced. And now I put these together. So I'm going to kind of skip some steps here. I'm going to put these two together and those two together, and then I'm going to put them all into one fraction. So I'll have a plus 4 times 2x minus 3 minus 2a minus 3 times x plus 4 over the common denominator, which is a plus 4 times x plus 4, but then all of that over x minus a. Is that all right that I did that? What do you think I'm going to do now? What? Yeah, just multiply all this shit out, okay? It's going to suck, but let's just do all that and do all that, combine everything together. Hopefully stuff will clean up, and eventually, hopefully, this x minus a is going to go away. Hopefully, it will, all right? Now, I do have good news. If you do it right, if you do these problems correctly and you do all, correct algebra, it will cancel, all right? Something will cancel, but you got to get the algebra right. All right, so now I'm going to do this algebra. Let me do it over here. Limit x goes to a. All right, so I'm going to FOIL this all out. Okay, this one right here. So read it out to me, somebody. First term?
2ax.
2ax. Next term?
Minus 3a.
Minus 3a. Next term? Plus 8x. Next? Minus 12. Okay, that's your first foiling out of the top left, right? Now I write minus, right? Now, aren't I going to subtract whatever these two become? I'm going to subtract the whole thing, right? So you better put a parentheses around what you're about to do. So let's now do this. So what's the first term here? 2ax. Next one. 8a. Next term. Minus 3x. Last one. Minus 12. That's just algebra, right? It's just algebra. I say it that way, but I mean, I understand. This is the weakness, right? This is the problem in calculus. Look, when I was sitting in the seat you're in right now, okay, I was not an algebra, I didn't feel comfortable with algebra the way I feel comfortable with it now. I got good at it because I had to do this, right? The more you do this, the better your algebra becomes. But if your algebra is weak and you just give up right now, it's never going to happen for you. You have to address your weaknesses in algebra. You have to sit down and do this, FOIL, practice, 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 so that you don't make mistakes. All right? Now I'm going to distribute the negative through. All right, I'm going to distribute. Yes, I'm going to rewrite the whole thing. All right, limit x goes to a. Okay, 2ax minus 3a plus 8x minus 12 minus 2ax minus 8a plus 3x plus 12. All of that over my common denominator. All of that over x minus a. And if there's any justice in the world, which I guess there isn't, then things are going to get good for us here. Wait, that 3a didn't cancel. Why did I do that? That 3a did not cancel. I got overambitious there. The 2ax's do, right? What else goes? 12s go? What else? That's it? Yeah, I thought we'd have more than that. All right, well, we're going to be able to combine like terms. Do we? Yeah, we have like terms, don't we? Let's go ahead and do that. I don't want to have to do that on another line. Let's go ahead and combine like terms. Hey, have y'all noticed my limit is in front of every single one of these expressions? Yep. Yours should be as well. All right, so what is the new numerator? Combine like terms.
11x minus 11a.
It's 11x minus 11a over the common a plus 4, x plus 4 over x minus a. Do y'all see it? What can you do? Take an 11 out of the numerator. right? These both have an 11, and then you'll have x minus a up here, and then it'll cancel. So limit x goes to a, 11, x minus a comes out. You've got your common denominator, a plus 4, x plus 4, and then over the x minus a. Now at this point, right here, you can cancel these, all right? I'm happy with you canceling them right here. But if you're still not sure why you're allowed to cancel that way, think about it as being x minus a over 1 here, and that it flips and becomes 1 over x minus a here, and then they go away, all right? If that helps you see why. So now I'm left with limit x goes to a. All right, what am I left with? 11 over a, a plus 4, x plus 4? Finally.
It's not worse than proofs.
It's not worse than proofs. Yeah, I agree. All right, now what are we doing? Let x become a, right? Let x become a now. So if I let that x become a, what I'm left with, no more limit 11 over a plus 4 times a plus 4 again. Well, isn't a plus 4 times a plus 4 squared?
Yeah, on those days.
Yeah, so this is the answer now. 11 over a plus 4, that quantity squared. That is the master formula. I will now provide you the slope of the tangent line to that curve at any point. You just need to give me the point. So for this part, any questions? For this part B, I need the equation of the tangent line, don't I? Well, I need to start with the slope. Like I need the slope to get the equation. So let's get the slope of the tangent line at this point. So what am I doing? -3 into this, right? The thing we just worked really hard to get. So this is going to be 11 over -3 plus 4 squared. I made it -3 on purpose. I wanted it to be a nice number here. So that's just 1 squared. So our answer is just 11, right? That's the slope of the tangent line there. We need one more thing to get the equation. What? A point on the curve, right? So we just need the y value off of that because we already have the x value. The x value is -3. So this is our slope, right? So as far as the point on the graph, we know the x coordinate's -3. The y coordinate is whatever we get when we plug -3 into this. What do we get when we plug -3 into that? 2 times -3 minus 3 over -3 plus 1, or plus 4. Top is -9, bottom is 1, so -9. You have a point, you have a slope. You're back in college algebra. You're happy. Y minus y1 equals m x minus x1, right? So what's that going to become? You go ahead and think about it. I'm going to graph it, and we're going to look and see if we got it. So new function, the new function here is 2x minus 3 over x plus 4. Get rid of this one. The point that we were looking at was the point -3, -9. There's the graph of the function. Do y'all see the point right there? That's -3, -9. And now I'm going to type in the equation that we just got and see if it looks right. So it's y, you tell me, y plus 9 equals 11 times x plus 3, the quantity x plus 3. There it is. Look, that's right. Well, it looks right. Doesn't it look right? Just gave you the equation of that line that touches that curve at one point and runs tangent to the curve. Here's a, yes, go ahead.
Do we expect this level of algebra on the test?
Oh yeah, absolutely. Yeah, this is what you're here for. This is what you're here to do. Yeah. Okay. So let's see if you can answer a deeper question. Let's say, take yourself back to college algebra. Okay, take yourself back to college algebra, or even take yourself to pre-cal. All right. Think about having a function that does something like this, all right? What if I wanted to know where that point, and that point were? Like, in other words, I wanted to know, where does that happen? Where do I have these peaks and valleys? That would happen when the what is 0?
Slope.
What's the slope, though? The slope of what?
Slope of the line.
The slope of the, you're almost there, the slope of the tangent line. I mean, I know you're thinking it right, but we want to say it right as well. So do you all agree that these high and low points correspond to when the slope of the tangent line is 0? Yes? And aren't we finding a way to come up with a formula for the slope of the tangent line?
Yes.
So to find those points, all I need to do is take that formula and do what with it? Figure out when it's equal to 0, which means I need to set that equal to 0 and solve that equation. If I do that, then I will be able to find the peaks and valleys of a function. Making sense? So coming up with this formula is critical for us being able to find peaks and valleys of functions. Okay? So we're just getting into how do we come up with the formula? How do we do this? All right, so that's to be continued. We're going to go back here. So look, this is such an important thing, all right? This is such an important thing. This finding the slope of the tangent line, right, is so critical to us that we actually have a name for this, all right? You start with a function, right? You start with a function, and you find the slope of the tangent line. You come up with this formula, this generic formula, right? The name of this formula is the derivative of this function. That's what it's called. Right, so I'm going to bring up my notes. You know what? I'll write it on the board. The derivative of the function f at x equals a. Okay, I'm about to define what this is. The derivative, right? The derivative of some function at some value of a, by definition, is simply this. It's equal to the limit as x approaches a of f of x minus f of a over x minus a. That should not look new to you, right? That's what we've been doing. The slope of the tangent line is, by definition, called the derivative of the function at a. And we have a special notation for it. Here's what we write. We will write over here. We don't write slope of tangent anymore. What we're going to do is this. We're going to write f of a, because isn't this a function? I mean, look at this. This is a function. You give me a, I give you an answer. You give me a, I give you an answer, right? So this takes an input of a and spits out an answer. But what I'm going to do is put this mark on it, and this is called the prime mark. We say this f prime. F prime. F prime of a, I should say of a. Of a. That's the way you say that. F prime of a. So this is new notation. Pardon? Yeah, this is a condensed way of me asking you the same question. So right here, what I could have done, instead of asking you to do part A here, right? What I could have done instead, a new question we could ask, this question could have been replaced with find f prime of a. And then you're going to do the exact same work. You're going to just take the limit and blah, 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 blah. You're going to get a formula at the end. All right? How are we doing on time? I think I have enough time to do one more.
A?
F prime. Oh, yeah. So if, yeah, someone could ask you for f prime of 2, right? You could say, what's f prime of 2? So then you could use the formula and replace all your a's with 2's, or you could get the generic formula and then replace your a with 2 here. That's up to you. It's usually harder work to find the general, but it's way, way better. That's really where we want to go with this. All right, I want to do this one. This one I think is going to be, yeah, let's not say fun. All right, for this one, I'm going to give you the function f of x equals x to the 4th. And let's find this. So basically, I'm asking you to find the slope of the tangent line at A, right? That's what that means? Find the slope of the tangent line at A. So it's the same thing we've been doing, just a different sort of notation for it. So this, by definition, is the limit as x approaches A of f of x minus f of A over x minus A. That's just the definition of it, right? Now for this particular problem, right, for this particular problem, f of x is what? X to the 4th. And f of A is a to the 4th. And this is all over x minus a. So this actually doesn't look too bad, does it? It's not that bad. As long, well, don't do this, please. Don't do this. Don't like cancel an x there, make that x cubed. Don't cancel those, and you know what I mean? No, you can't do that, right? Because you have subtraction between those, you can't? Do you all agree you can't? All right, so what can you do?
Quadruples.
Do what?
X squared plus a squared times x squared minus a squared.
So see this is a difference of squares, right? So we're going to turn that numerator into x squared plus a squared times x squared minus a squared. Is that legal? Yes, right? That's a difference of squares on top. Nothing cancels yet, right? However,